Support for Lab Out Loud is provided by the National Science Teachers Association. Join thousands of science educators at the NSTA 2016 Area Conference in Portland. It runs from November 10th through the 12th. The conference themes will focus on collaborating to integrate elementary science instruction with math and ELA, celebrating science for all, and connecting three-dimensional science instruction. The deadline for early bird registration is Friday, September 30th. Learn more about this conference and others at nsta.org/conferences. Welcome to the Lab Out Loud podcast, science for the classroom and beyond. And today we're talking about one of the summer's biggest crazes, it's Pokemon, and how can we use it in the science classroom?
One thing to keep in mind is that what Pokemon is really doing is it's not inventing a misconception, it's simply bringing a very common one or a set of common ones to the fore. In some ways, it's kind of an opportunity because misconceptions that might just be kind of under the, they're not at the surface when you're engaging students. Here, they're very much at the surface, so you can kind of engage, okay, what do you think about this? It's a nice way to say, okay, this is what Pokemon call evolution. Given what we've learned about evolution, how is this not biological evolution?
Get ready to talk Pokemon science, but first, this is Lab Out Loud, and I'm your co-host, Dale Basler.
And I'm Brian Bartel.
And we're back for our 10th season of Lab Out Loud, and we just got back from the summer, and everybody should be back in classes by this point.
Yeah, some of you have been in school for a few weeks even, and hey, we just started a few days ago, but we're ready to get started.
We do know that one of the things that really took off this summer was a new interest in Pokemon with the hit game, Pokemon GO this summer. Did you play it, Brian? I know you played it.
I did, actually. I mean, hey, it was kind of a fun thing to do. And as we deal with technology in schools, I like to think of it as job research. At least that's what I told my wife when she was annoyed
it's like looking up what kind of music your kids are listening to and things like that. Yeah. Me, like many teachers, I think you gave a look at it and you're saying, well, how can I use this in the classroom? I made a short little video. We'll post it in the show notes, but I looked at the mass and heights of all the Pokemon and started to figure out what the densities would be. And I thought, well, this could be a good physical science, freshman, middle school lab, where you could almost make a density tower of Pokemon and stack them up and compare the densities.
I think the best part of the video, though, was like when you talked about how everyone has to do the obligatory like density calculation worksheet, right?
Yeah.
Because, hey, what is a tube of copper? Well, who has that lying around? I mean, I'm not a plumber.
Yes.
So.
Yeah, and and I make the argument that our kids probably saw a lot more Weedles this summer than they did seeing a block of aluminum or whatever is in those density worksheets.
Anyhow, while Dale was focusing on the physical science aspect of it, I, of course, tuned into the part where we can evolve Pokemon from one organism to another. And, of course, that's not exactly what we want kids to have as a takeaway message of what evolution is. So we decided to talk to an expert and even someone who's used Pokemon in their classroom. So we welcome Professor Luke Holbrook. He is at Rowan University in biological sciences. He has a few classes there. One of them looks really cool called Biology, History, and the Fate of Human Societies.
I'm a vertebrate paleontologist. I study fossil mammals, and I am very interested in the relationships among different groups of organisms, which is actually relevant to what we'll be discussing today. So I look at sort of the evolutionary tree of mammals, especially looking at how they diversified right after the extinction of the dinosaurs through maybe the first 20 million years there.
Okay.
And I teach a lot on evolution and here at Rowan as well.
So did Lucy fall out of a tree or not?
That's what the paper says.
I was just hearing that on Science Friday as I was coming in today.
What did I miss?
We'll catch you up, Dale. So
okay,
anyhow,
all right.
yeah. So you've used Pokemon before in your classroom. Can you tell us a little bit about that?
Sure, and I should say I have a daughter who plays Pokemon GO now, but this was before I really knew very much about Pokemon at all. This is when I first started at Rowan, basically. I was going to be teaching some evolution courses and wanted to teach about phylogeny, which is how different groups of organisms are related to one another. And I thought, well, what I just need is something that has some different kinds of things, different sort of creatures maybe, and I could give them to the class, and then they could try to come up with a tree for those organisms. And I was aware of Pokemon, and I said, hey, why don't I try those? So I went to the grocery store, and they had a bunch of Pokemon cards right at the cash register, so I just bought a bunch of those, and I would give each group of students a set of cards and say, go make a, we had talked about how we go about trying to come up with these trees. And so I said, okay, here's your cards, and go ahead and try to make a tree. And I did it for, I think, a couple of years, and then I kind of dropped it for a few reasons. One was I kind of felt like it was tending to reinforce certain misconceptions. So as people anybody who's familiar with Pokemon may be aware, they have something called evolution. So, which is really one sort of weaker Pokemon changing into a stronger kind of form, which is in some sense a different kind of Pokemon, so a different species, if you want to call it that.
Mm-hmm.
But that's not, it's kind of several misconceptions of evolution. One is the idea that individuals changing from one form to another is evolution, which is not an accurate description of the process of biological evolution. So biological evolution, you have a population and individuals are different from each other, and the population can change because you get more of this kind of individual versus another kind because of selection based on environmental conditions. And you also might have conditions where populations that were part of the same species start to evolve differently in different parts of their ranges, and then they become so different that they no longer can interbreed. And that's really a population level kind of phenomenon, and Pokemon is not population level. It's looking at individuals changing from one type to another. So that's very much a misconception, as well as it kind of suggests that evolution is progressive, that why they're evolving.
There's a goal.
They want to become better. In fact, they can even mega evolve is another apparently something they'll do, which is they evolve even more. And so it's very much.
How many coins does that take?
Well, and actually there's a limit too. There's a stopping point for some Pokemon.
Oh, yeah,
so they
yeah,
can't
top out.
evolve. Yeah, exactly. They've reached their pentultimate Pokemon.
Yeah, so there's even one Pokemon called Eevee, which can evolve in a lot of different ways. So there's like 9 different evolutions of it. And they're not
in the game
sequential.
You can go change their name, and then you can dictate which way they evolve. And I felt like while I was doing that, I was like, this is a intelligent design here. I was controlling that.
Yes, my daughter has been changing the names of my Pokemon to
but if you change the name of the Eevee to its little sister name or whatever, like, so if you change your Eevee to Sparky and then evolve it, it'll evolve to the electric one.
Yes, and she was changing the name to like Rainer or something like that, try to get it to become the water type. Anyway, so it's got this misconception that evolution is a progressive kind of phenomenon. And I didn't even realize this phenomenon existed in Pokemon until I started doing this exercise. And I realized there were students who were familiar with Pokemon, and they immediately recognized if they happened to have the Pokemon and its evolution, they would kind of put them together, which was fine. That was okay. They recognized some kind of, the whole point is we look for similarities that will group things together as evidence that they might be related to one another. And so they might have, the evolved form and the not evolved form would be similar in that sense. That wouldn't be so bad in terms of the logic they'd be using. But really, they were making more of a linear jump. They were thinking they had an ancestor and a descendant, and that's usually not what we have when we're making these trees. Even when we have fossils, it's really unlikely that the fossils we have are actual ancestors of any of the groups we're looking at. We can talk about how they're related, so they could be long-lost cousins, essentially, of a group, but they're not necessarily going to be the ancestors. So, so those were some of the misconceptions that I felt were kind of too embedded in Pokemon to make it really effective as an activity.
When did you do that activity?
It was a lab that we did in, I believe it was either, I probably used it in 2 different ways. One is in an introductory course where we had a module on evolution and phylogeny. And I probably used elements of it in the upper level evolution course I was teaching as well.
Was it years ago, or is it recent?
Oh yeah, this was in the early 2000s that I was doing this. So there was I don't even know what DS game might have been.
So what are your thoughts now, given that it's, basically being reinvigorated in popularity?
Well, that was one of the first things that occurred to me was, since the evolutions, they've been embedded in the game, including its, other digital forms, and in the movies and things like that. My daughter, we were watching one last night, in fact. And I've talked to my daughter about it, and she's going into 6th grade, and I know in school they've already talked about evolution, and I've kind of said, this isn't really what evolution is like for in biology, and she seems to understand that, but it will really come down to when she's engaging biology, at a higher level, that she'll probably have to engage. Well, what does it really mean for evolution to happen? Sure. So I think one thing to keep in mind is that what Pokemon is really doing is it's not inventing a misconception. It's simply bringing a very common one or a set of common ones to the fore. So in some ways, it's kind of an opportunity because these misconceptions that might just be kind of under the, they're not at the surface when you're engaging students, Here they're very much at the surface, so you can kind of engage. Okay, what do you think about this? And this was the connection here was Stephanie Keep at NCSE had written this blog post about kind of this whole thing about the misconceptions of evolution in Pokemon, and I'd made a comment about this particular, I tried Pokemon and I kind of dropped it, and she said, this you could reintroduce it as a let's look at this as a misconception, kind of to show students how it's a misconception, and that is probably something I'll do because it's a nice way to say, okay, this is what Pokemon call evolution. Given what we've learned about evolution, how is this not biological evolution? So
yeah. So now a question I might have is that, it sounds like you said, okay, I had a lab on this, which of course that must have meant all the kids are like, hey, this professor's got a Pokemon lab, so we got to sign up for this course. But you had it in a lab, and it sounds like you were frustrated because it may have taken, again, bringing those misconceptions to the surface that you weren't maybe completely able to address in a lab setting or, But let's say maybe you had, could you do a course on Pokemon, like teaching evolution with Pokemon and addressing those misconceptions head on? Because, even just in the conversation you had, you'd mentioned population biology and, how fast does evolution take? That would be a chance to talk about gradualism versus punctuated equilibrium and, a lot of other things too. Is there a goal for evolution or not, an end to it? Maybe that would be a better way to tackle it is evolution just by Pokemon as a whole, draw it out over many days.
Well, and I think the idea to have a whole course where you would make that the center is kind of interesting, but one of the other reasons I ended up, the other sort of half of the reasons in some way of why I ended up kind of dropping the Pokemon example, because there are actually other exercises that people have developed with fake organisms that you use to try to illustrate these same concepts. And one of the conclusions I kind of came to is, especially teaching college students to be biologists, I want them to think of themselves as scientists. And the more that they deal with real data and real organisms, that is probably better. So for instance, now I give them data on primates, and they play with it, and they use analytical programs to come up with the trees and to analyze the data. And one of the things about the real data is that there are real patterns that those data are capturing. So they get to see, the reason we can use these data is because there's a biological reality behind them that will give us some kind of pattern that we can recover from that. And that's not necessarily true with Pokemon. So one way you could use that, though, as a way to kind of maybe expand that is, okay, if I give you data and you get a pattern out of it, how do you know that you'll always get a pattern, regardless of whether the data are real organisms or fake organisms? And it might be interesting to do an exercise where after you have them work with real data and get a real pattern, that they then work with these Pokemon and they come up in maybe in different groups, and they realize they're all getting very different answers. And that shows them that maybe there's not such a clear pattern in these data. And why? Well, they're not actually real organisms. There is no evolutionary history that unites them that would produce those data to give you a pattern. So that's actually, in thinking about all this, that was kind of one thing I thought about. How can you use actually these artificial organisms as a way to illustrate that, that the methods you're using give you interesting patterns because those patterns exist, and when they don't, you're going to get a lot more noise and get more random patterns. Yeah, you'll get a pattern, but you won't be able to reproduce that pattern if somebody else analyzes the same data, essentially, or analyzes the same organisms and comes up with their ideas of what are the similarities among them.
So it sounds like if a biology teacher, high school biology teacher that's listening right now is thinking about, introducing Pokemon into the classroom to sort of trigger a discussion about evolution, that you think that might be a good approach.
I think it could be, but I think you want to pair it with something that you can look to say, look, here, the things we're going to do with the Pokemon are, can we mirror them with what scientists do or what we know about evolution when we look in the biological world, so they can kind of contrast how we look at biological evolution with this completely other fictional concept of evolution.
Sure.
So you got to set some ground rules, like we're following the laws of nature here, kids.
Yeah. Well, I think about Pokemon Go is a game. Would we still have a game if we come back to reality here? I mean, how would the game change? I mean, we think about things like winning and...
Right. Well, for instance, you might ask them, well, if Pokemon are going to evolve, what would be, first of all, what might be the outcome of that, right? So they might understand that, evolution doesn't mean I become a more powerful Pokemon necessarily. It would look at the variation among Pokemon, and actually one way you could potentially do this, I suppose, there's all these different types of Pokemon. There is a classification, essentially, of Pokemon.
Isn't it crazy? When you first looked at the Pokemon thing, weren't you just amazed at the depth?
Yeah, I thought it had all these. I thought it had there's lots of things they could kind of pull out of the cards, even just to get traits, essentially, and that they could compare among them. I was even originally just thinking, they'd look at, this one actually has 4 legs, and this one has ears. And
well, and I'm sure you may have known too, there's actually a constructed phylogeny that was published in the Annals of Improbable Research.
I think I heard about it and I haven't seen it.
Well, it was out a few years ago, and it has had a resurgence because of Pokemon Go, and it's interesting. So I was curious if you ever this came out in 2012 in the summer. So again, this was in low Pokemon, I guess, interest, and now it's kind of brought to the surface. Pokelull, yeah.
Pokelull.
It's been brought back to the surface, and it's cute because there's these hand-drawn pictures of Pokemon, which is now, obviously, we have much better graphics we can use. But I was curious if you looked at the phylogeny and wondered if and matched anything your students did to it, and see if there was agreement or disagreement, and why that might be.
Well, I can't say I have looked at it. I've tempted to just go look for it now. But I would. One of the things I would imagine might happen is you might get. When you come up with a phylogeny, you want to have data to support it. So basically, in fact, you can come up with all the possible phylogenies. But for all the Pokemon that are out there, it's the number of possible phylogenies easily outnumbers the number of atoms in the universe. But in theory, there's a finite number, and what you're really looking for is which of those is the best supported, which is actually is best supported by data that you're examining.
Well, and I suppose there could be a conversation too. Is this person had this phylogeny based on this data set, and this is different from another group. And if why would that happen? And that was more of an older model of how we used to do, phylogenetic trees there. And so, that could be some of the flaws in how we used to the group organisms. Now we have a lot more data. We can add in DNA. We can add in other things that say, yep, this is why they're related this way.
So I guess would you be saying that we would, are the data being generated by the students? Or, because it's interesting, there's lots of links here for different phylogenies of Pokemon.
Yeah. Yeah, I got you down the click spiral, didn't I? No, I'm just saying, like, if you had them do this as an activity, you could talk about the limitations of the data that's available just in the Pokedex, that, you can't get everything that you want. And because of this, there's a lot of interpretation and subjective outcomes that come about. And what kind of data would allow you to make a more convincing phylogenetic tree? That, and
right. Well,
that could be a conversation about, 20 years ago we didn't have this, but now we do, and so this is how that's improved.
Well, and actually, I could see how you sort of take a variation on that. So, sort of one idea where we're kind of
this is the lesson planning nerding out that we're having.
Yeah, no doubt.
Sure. Well, and that's I suppose that's what we want some of this to be the takeaway is like, well, how can you use this to because as I said, these are not new misconceptions. It's just Pokemon actually gives you an opportunity to kind of address them.
Yep.
So if you had, say, a bunch of groups of students individually coming up with their own phylogeny, and you're going to see a lot of conflict between those, what they come up with, because they're, the data aren't really very helpful probably for that. But, and one of the things we use to kind of, that helps us say, yeah, there really is this is a pattern that's a real biological pattern, is when different kinds of data actually give you the same answers. And so here you'd be using the same data and you're getting different answers, right? Which is not that surprising because it's not, they're not real creatures. But then you could compare that. So we do another exercise. In fact, the exercise we do, as I mentioned, I've gone to using real data, and we do this exercise with primates and some DNA sequences, and they come up with, actually it's a couple of trees that differ in one small way to show like, these data give us a lot of the pattern, but there's a little bit of uncertainty in it. Mm-hmm. And then we do another exercise where we give them 3 different studies using 3 different kinds of data. And they're different from the data that they used. And they have to take those results and kind of compare them. So the results are not presented in exactly the same way, so they have to learn how to make those comparisons. And one of the things they're supposed to pull out of that is, well, these results actually all say the same thing. And that's actually a very, it's one of the more convincing demonstrations that there's a real biological pattern here. And it's also it's also one of the better ways to demonstrate evidence for macroevolution. So when you're talking about, especially if you have anyone who's resistant to the ideas of evolution or doesn't understand the scientific evidence or demonstration or testing of it, usually with microevolution at the population level, people who have issues with evolution have kind of given way on that. They recognize there's lots of laboratory data and field data that have demonstrated that populations do evolve. Mm-hmm. But then they'll kind of pull their lines back to, well, macroevolution doesn't happen. How do you get these patterns where you have different species? And well, one of the tests of that should be, well, if there really is a phylogeny out there, if there's really macroevolution, there should be a phylogeny. There should be an evolutionary tree. And if there's an evolutionary tree, then we should expect that we could recover that tree using different kinds of data, that those data should basically give us the same tree. Sure. And that's kind of what we demonstrate with this primate one, where they have some anatomical data, a couple of different kinds of anatomical data, and actually they're given the trees from some anatomical data and another one using some different DNA data from the data that they used. And when they compare all those trees, all 4 of those kinds of things, kind of studies, they see, oh yeah, these are actually telling me the exact same thing, basically. And whereas I would expect that Pokemon would not tell you that, even though all the students were looking at the exact same Pokemon.
Yeah.
You know,
Have either of you looked at No Man's Sky that's come out, the video game? I've been reading about it and hearing about it. Maybe it's going to be a future episode, but it's way beyond a cell phone game.
I can hear Luke clicking.
But it
yes, I've heard of it now.
Yes, I'm very smart with the internet. It's I'm reading off of Wikipedia, but I've seen like some intro videos to it. But essentially, you go in, you keep discovering planets. On those planets are different animals, and they have some sort of engine that's driving how the creatures are being created, how the plants are being created. I'm reading this. No Man's Sky uses parametric generation equations that mimic natural forms in nature, such as L systems that can create a variety of types of trees.
So I guess my question would be: are they simulating an evolutionary history on the planet, or?
Yeah, I just don't. We'll call you next year on this one.
Well, I mean, that even harkens back to, if you remember the game Spore.
Yes,
and then talking
that was the other one I was trying
evolution.
to think of.
Yeah.
No, that was another one. Well, before we let go, Luke, the other thing, and I guess Luke and Brian, you guys being biology teachers, one thing I thought about is not the evolution side, not the creatures themselves, but the idea of collecting them all. Doesn't that kind of lend a nod to what, Darwin was really doing with his sketches as a naturalist? And I mean, it could be kind of a springboard to the idea of being a citizen scientist. You can, collect the bird sounds in your neighborhood or things like that.
I think a lot of people are trying to capitalize on that exactly. I keep seeing things about how Pokemon GO may lead to this increase in people doing bird watching and trying to kind of take that same approach to and not only doing bird watching, but basically collecting data that.
I think there's some leaf projects. There's an app where you can take pictures of different leaves. Some different citizen scientist kind of initiatives.
Yeah.
Yeah. So I think there's people are recognizing that just this kind of this collecting instinct that seems to kind of engage us very strongly, and certainly kids. My daughter plays Pokemon. She does the game, but she seems to be most fascinated by the fact that there are just lots of different kinds of Pokemon. And she wants to know all of them, and as opposed to I want to be the gym master,
Yeah. And that's kind of neat that I think there's two strands of players going on there, and which one did you get? Oh, I haven't seen that one yet. And, I mean, kids, we can do that in the natural world too.
Yeah. I mean, you mentioned there had been kind of how Pokemon had kind of fallen off, and we hadn't really played it very much. But then we went on vacation, and we were in a different part of the country, and we're like, hey, there's different Pokemon here. So we were.
Oh, that happened to you too, Brian, right?
When I was at the Mall of America, they have the aquarium there, and there was all the sea life Pokemon that was like, whoa.
Yep, that happened to us. We were in Florida, and there was lots of, of course they have things that are very common, at least for there. And I'm thinking, well, I'm probably not going to see all these Magikarps when I get back home. Maybe I should catch as many as I can here, but we would see a whole different set of these creatures, and I
wonder if anyone's worked out geographical areas. Obviously, there's water versus land, but is there a Pokemon that shows up in Wisconsin the most?
Or migration patterns?
Yeah, there we go.
I wouldn't be surprised if there is. In fact, I thought I had heard something to that effect that people had mapped out. And in fact, I think my daughter was like, I'm going to look and see if I can. I'm just going to Google where can I find this Pokemon and Pokemon Go. And I don't remember what she got out of it, but that seems like a question that somebody has tried to answer probably. And and I don't know how they're distributed globally. They're certainly distributed environmentally. Ecologically, essentially, but is there also, global differences?
We could talk all weekend about Pokemon because I think there's a lot of really cool things that have come up from this discussion, and those are some great questions. Luke, we thank you so much for your time. If listeners, if you have any ideas and want to share how you have used Pokemon in class,
Or plan to.
let us know. Or plan to. Yeah, we'd love to see what you've done.
Yeah, well, thank you guys for inviting me. I had a lot of fun.
Thanks a lot, Luke.
Thanks much. For links and other information related to this episode, visit laboutloud.com. You can send us your questions and comments at laboutloud.com/contact.
If you enjoyed the show, make sure you've subscribed on iTunes, Google Play Music, Stitcher, or your favorite podcasting platform. And if you really enjoyed it, consider leaving us a rating or a review. Your feedback helps others find our show.
Until next time, I'm Dale Basler.
And I'm Brian Bartel.